We will start with oscillation waves. Start with oscillation waves. जो पीपल की पत्ते होते हैं वो भी हिलते रहता है. एक सिंपल पेंडुलम used to oscillate about its equilibrium position. A spring mass system on a smooth surface used to oscillate. All are called as but oscillatory motion. बहुत सारे एग्जाम्पल होगा, बाद में बताऊंगा. So before thinking about the position with respect to time, velocity, oscillation, where the particle is, we should analyze better more. Like first we start with periodic motion. Periodic motion. What periodic motion is? If in a particular motion, position, acceleration, velocity in vector form all are repeated at equal interval of time. At equal interval of time, the motion is called as periodic motion. Okay, let me say this x, v, and oscillation is called an event. So you can say if all the events of a motion are repeated at equal interval of time, that motion is called as periodic motion. Example, uniform circular motion. Particularly at a certain point A, its position vector, velocity vector, and oscillation vector. When particle reaches at point A again, that same event means velocity, oscillation, position will be repeated. If the radius is r, particle to reach the same point A, to event to be repeated, time taken is 2 pi r by v. This is called as time period. Time period of this periodic motion. So the whole, if an event is repeated at equal interval of time, the motion is called as periodic motion. Another example, there is a particle moving with velocity v on a smooth surface. All the collisions are elastic with the wall. Separation between the walls is L. This motion also called as periodic motion. Once particle move rightward, then return to the same point, the motion is not repeated because velocity is in opposite direction. So v vector is not repeated. But once the particle moves back to somewhat left and returns back to same position, all this motion, all these events will be repeated. Means position, velocity, acceleration zero रहेगा because the smooth surface. So at this position again, motion is repeated. So for this motion, time period is 2L by V, and the motion is periodic. So if in a motion, every event is repeated at equal interval of time, the motion is called as periodic motion. This motion is oscillatory motion. This to and fro motion is called oscillatory motion. But circular motion is not an oscillatory motion, but it's a periodic motion. It's not an oscillatory motion. But this motion, to and fro motion, collision with wall, can be called as an oscillatory motion. You can pause the video at any time. Next is harmonic motion. What is harmonic motion? What is harmonic motion? Oscillatory motions. Oscillatory motion. Oscillatory periodic motion. Oscillatory periodic motion. Without any collision. Without any collision. Collision means there are no impulsive forces acting over it. Without any collision is called as harmonic motion. Just the last question था, दो wall का बीच में particle oscillate कर रहा था, but in this case there is some collision at the end points, so it is not an harmonic motion. Periodic oscillatory motion without any collision is called as harmonic motion. Let's try to analyze about harmonic motion. An oscillatory motion without any collision, this must be periodic, then it is called as harmonic motion. If there is no collision at extreme points, velocity will be zero. Extreme point. At both the extreme point, velocity must be zero. So at a certain point, velocity should be maximum. Where velocity is maximum, their oscillation is zero. That is called as mean position. Mean position. Once particle is moving from mean position to extreme position, as velocity goes on decreasing, acceleration is leftward. And from this left side, acceleration must be rightward. So acceleration always directed towards the mean position. Acceleration always directed towards mean position. So we'll take a position vector with respect to mean position. We will take a position vector with respect to mean position of particle. A cap must be minus r cap. Means acceleration and r vector always opposite in direction. And acceleration at the mean position should be zero. So acceleration vector should be proportional to r mod of r to the power n. If this both the conditions satisfied, then the motion is called as harmonic motion. अगर both conditions satisfy होगा, the motion can be called as harmonic motion. And what is simple harmonic motion? Simple harmonic motion. Simplest form of harmonic motion. If n equal to 1, if this n equal to 1, then that motion can be called as simple harmonic motion. Means if oscillation vector is equal to something minus constant, k is a positive constant. Positive constant into position vector. This is the only proof the motion can be shaped to simple harmonic motion. If somebody will ask you, the motion is simple harmonic or not, first you have to prove, think about that motion is oscillatory or not. If motion is oscillatory, then try to prove A vector equal to minus k r vector. R vector is always position vector of the particle with respect to mean position. That motion can be called as simple harmonic motion. When it is simple harmonic, it must be periodic. Harmonic or simple harmonic motions must be periodic motions. Okay. Anytime you can pause the video, try to analyze it better. Let me say spring mass system. Spring constant K. And the mass is oscillating on a horizontal smooth surface. Somebody will ask you, prove that the motion is simple harmonic or not. At any distance x, here oscillation at the natural length of the spring, oscillation must be 0 because kx is 0. At any distance x from the mean position, oscillation written as force by mass. Force is minus kx by mass, as oscillation is equal to minus k by m is a constant. So oscillation is proportional to minus x. So the motion is simple harmonic. One more question will ask you, the motion is simple harmonic or not? Feel that first the motion is oscillatory or not. Once it is oscillatory, try to prove oscillation equal to minus some constant into x. X means position vector with respect to mean position. Then the motion can be said to be simple harmonic motion. So this motion is simple harmonic in nature. Somebody will ask you, in the last question, spring mass system oscillating without gravity, because gravity is there, but there is no effect of gravity in the motion. But if the spring mass system oscillates vertically, you have to prove the motion is simple harmonic or not. The mass is, let me say, oscillating in this vertical line, somewhat like this. First, you have to find the mean position. At the mean position, always oscillation equal to 0. At mean position, oscillation must be 0. If I take downward as y, positive y, at the mean position, as oscillation is 0, the force acting upward, let me say k y naught is expansion, and downward force is mg. If k y naught equal to mg, at that position, the oscillation is 0. Net force is 0, means oscillation is 0. That position is called as mean position. For further y expansion, further y means y from mean position, the force acting is minus k y naught plus y plus mg equal to mass into oscillation. I have taken downward as positive. Again, you got acceleration equal to minus ky by m, same as last question, same as last example I have just said. Acceleration equal to minus a constant k by m into y. Again, the motion is simple harmonic. So to prove the motion is simple harmonic or not, first think about oscillatory motion, then think about oscillation must be proportional to minus y. Motion can be called as simple harmonic. A particle moving on x-axis, the position is given as, let me say, a sine omega t plus phi. A and omega are omega phi are positive constant. A omega should be positive constant. Okay, A omega are constant. A must be positive, omega must be positive, phi may or may not be positive. Prove that the motion is simple harmonic or not. You would think about oscillation, first find velocity. as dx by dt, you'll get as omega a cos omega t plus phi. Think about oscillation, dv by dt, you'll get minus omega square a sin omega t plus phi. As omega is a constant, positive constant, a also positive constant, so that written as minus omega square a. A sin omega t is x, omega square x. According to this question, omega is a constant. As omega is a positive constant, omega square might be positive. Oscillation is proportional to minus x. Again, motion is simple harmonic. So to prove simple harmonic motion, think about oscillatory motion, then think about oscillation. It is proportional to minus x. That's the proof of simple harmonic motion. So in this case, about x is equal to 0, in this example, about x is equal to 0, the particle is oscillating. So x is equal to 0 is the mean position, but at x equal to 0, the oscillation is 0. So about x is equal to 0, the particle is to oscillate. And extreme point will be at a, because the value of x maximum is a. This also a. This a is called as amplitude of the motion. This a is called as amplitude of the motion. So amplitude means what? The separation between mean position and either extreme position, any extreme position. In case of SM, both the extreme point should be at same distance from the mean position, which is called as amplitude of the motion. If somebody asks you, if x equal to some a1 plus a2 sin omega t plus phi, this motion is simple harmonic or not? This a2 sin omega t plus phi is a simple harmonic motion. Means a particle is oscillating with an amplitude a2. Think about the second part. Particle used to oscillate with an amplitude a2. Same as the last example here. This a1 is added up means x is equal to 0 somewhere here. At x equal to a1, particle at the mean position. So here a1 is mean position and a2 is amplitude of the motion. A1 is mean position, A2 is amplitude of the motion. So means general equation of SM must be A sin omega t plus phi, yes or no? When damping will start, in that case I'll give an example how the differential equation can be solved. But for the timing, we just to go over sine function. If any motion with x is equal to A sin omega t plus phi or this A1 plus A2 sin phi, called as simple harmonic motion. Now start derive. Okay, first a particle is an uniform circular motion. A particle is an uniform circular motion with constant omega on xy plane. On xy plane of radius a at time is equal to 0, particle at an angle phi naught with x-axis. But my question is, projection of the particle on y-axis is simple harmonic or not? The particle is an uniform circular motion on xy plane as shown in the figure. I have to prove the projection of the particle on y-axis is simple harmonic or not. First of all, projection used to oscillate between y is equal to a and y is equal to minus a. And that motion of the projection on y-axis is an oscillatory motion. Is an oscillatory motion. The projection of particle on y-axis is an oscillatory motion. But I have to prove that motion is simple harmonic or not. After any time t, the particle at an angle omega t from its initial position. So this projection on y-axis can be written as y is equal to a sine omega t plus phi naught. So this equation, just we have said this motion is simple harmonic, or you can write dy by dt equal to omega a cos omega t plus phi naught. And this part is velocity. And acceleration on y, dv by dt. I'm saying about only projection of y-axis. It is minus omega square a sine omega t plus phi naught. So again, acceleration is minus omega square y. So this motion is simple harmonic. So mean position at y is equal to 0. At y is equal to 0, the position is mean position. Just said this A is called as amplitude, separation between mean position and extreme position. So A is amplitude. This omega, in circular motion, this omega is called as angular velocity. That word is used in simple harmonic motion as angular frequency. This phi naught plus omega t is angle with a reference line x-axis. That is called as phase of simple harmonic motion. Angle in circular motion with x-axis called as phase for simple harmonic motion. And the phi naught can be called as initial phase. Means at time is equal to 0, that angle is phi naught. So that phi naught is called as initial phase. So when I would think about phase, think about uniform circular motion, angle with x-axis. And this velocity can be written as omega root over of s square minus y square. Y is mean from position of the particle with respect to mean position. Because in this case, mean position at y is equal to 0. And acceleration written as minus omega square y. So all this equation can be said as general equation of simple harmonic motion. When I think about phase, think about uniform circular motion. That is angle for that. All these are general equation of a simple harmonic motion. You can pause the video, write all the things. Start with a question, it's examples, but the question may be asked. Okay. First, time period. For circular motion, time period is 2 pi by omega. For circular motion, the same time period formula can be used for simple harmonic motion. One question was given. A particle is in simple harmonic motion on x-axis, whose oscillation versus x curve is given somewhat like this. This angle is theta from minus a to plus a. Particle used to stay between x equal to plus a and x equal to minus a. That oscillation versus x curve is given. This angle is given as theta. Let me say question asking find time period of the motion. Time period of the motion. I've just said it. Acceleration written as minus omega square x. So for acceleration x curve, the slope is minus omega square. And here slope is minus tan theta for this curve, for the straight line. So omega can written as root tan theta. And time period 2 pi by omega, 2 pi by root tan theta. So in this way, you can, once you got omega, you can find time period from this formula, 2 pi by omega. So whenever question asks you find time period of simple motion, try to find omega, means try to find acceleration as function of x. Once you got this equation, you can get omega, you can get time period of motion. A particle is in simple harmonic motion, another example, simple motion, whose velocity versus x curve at x equal to 0, it is mean position. Velocity versus x curve will be elliptical. Between plus a to minus a. Between maximum velocity to minus of maximum velocity. If maximum velocity is given and a is given, question may be asked to find the time period of the motion. Just have written v is equal to omega root over of s square minus x square if the particle is moving on x-axis and x equal to 0 is the mean position. I can write v max at the mean position obviously is omega a. So this v max is omega a and this a is known to you. You can get omega and you can find time period as 2 pi by omega. Now start with phase. You can put apart. Once I'll say about phase, let me think about circular motion, uniform circular motion. The projection on y-axis is simple harmonic. Starting any point. Once particle at this rotating with omega, this angle is called as phase for simple harmonic motion. So at mean position means y is equal to 0. I can say phase of the particle is 0 if the particle is moving upward. Particle at point C, let me say, moving upward, phase 0. Once it reaches at extreme point, phase becomes pi by 2. Particle is at this point, this angle is reference line with x-axis is pi by 2. Once you reach at the mean position again, in downward motion, phase becomes pi. Once at the lower extreme, phase is 3 pi by 2. Once it again reaches mean position, phase becomes 2 pi or 0 and cycle completes. So the complete cycle, phase change is 2 pi. Phase means angle in circular motion with respect to reference line. Somebody may okay, just have written x is equal to sorry y is equal to a sine omega t plus phi naught. I'm writing phi. This phi is called as phase. So phase can written as sine inverse y by a. Mathematically, phase can written as sine inverse y by a. Somebody will ask you a particle is in simple harmonic motion on y-axis, mean position at y is equal to 0. Particle at a distance a by 2 plus a by 2. A is amplitude. Find phase of the particle. I can use this equation. Phase of the particle is sine inverse a by 2 by a, sine inverse half. Sine inverse half is not a single value. It is pi by 6 or can written as pi minus pi by 6 means 5 pi by 6. Got two values of phase. What does it mean? When particle is moving upward, velocity upward, that phase is pi by 6. At same point when particle is moving downward, that phase is 5 pi by 6. Think about circular motion. You can analyze better. Means at a by 2, this angle is at a by 2. This angle is pi by 6. But this angle with x-axis is 5 pi by 6. So at plus a by 2 particle is twice with a phase pi by 6 or 5 pi by 6. So in this we can get phase of any point. The next class I will go with oscillation waves 2. For today it is over. Thank you. Thank you everybody.